All right, so now when we're doing natural logarithms, so if you have ln of x, it's called the natural log. It's right ln of x. And so the domain is all values such that the expression of ln after the ln has to be greater than 0. So if I'm trying to find the domain here, I want to set 4 minus x greater than 0. I'm going to make an inequality, and what I'm going to do is I'm going to solve that inequality. So let's say I subtract 4 first, subtract 4. So negative x is greater than negative 4. And then divide by negative 1, flip the sign. X is less than 4. So that's my domain. So less than 4 would be a domain less than, basically goes forever never low up until 4, not including 4. I don't include it because it can't equal 0. On B, I need to set x squared greater than 0. Okay? So x squared greater than 0. So on this one, okay, square root, x has got to be greater than 0. Now, on this one, though, it's a little different because it's a squared. Okay, let me explain why. I actually did that wrong here. Because on a squared, I caught myself. On a squared, if I have a negative number, you can't take the ln of a negative either. If I square it, it becomes positive. So in this case, I can't have a negative, which it wouldn't be possible to have a negative, but what would be the thing that would get me in trouble? It would be if it equals 0. So this can't be 0. So what square is going to be 0? 0. So thus x can't equal 0. Okay, because if I had a negative number for x, it's going to square and become positive. That won't be a problem. The only thing that would give me a problem is if this was 0, because 0 squared would give me 0. And I can't take the ln of a negative, which won't be a problem here, because any negative will be squared to be a positive. But 0 would give me a problem. So since x can't equal 0, I'm going to go from negative infinity up until 0, but not including 0, union 0 to infinity. So it's everything but 0.